Welcome again to Wickerson Studios. My name is Michael Wickerson, and I am continuing to take a look at the GH-Python tutorial that was put up online. Very helpful. I hope you find it interesting what I end up doing with the scripts. The scripts are definitely all of the scripts that came out of Niloofar Zaker's functions. And what I've done is applied those functions to some geometric applications, and then I'm on to the points and turning those into geometric applications. And I've just done one before this video, and what you're looking at is this simple GH-Python script applied to some post-node work in Grasshopper. And here's the shape that's actually made, and in the end, what's actually baked. If we take a look at it and bring it in here as grouped form, you'll see that really it's just the negative spaces. As I leave this, I'll just delete that, and there you go. You have a bunch of spheres that have cubes or boxes that have been rotated but then removed from within them. And you see some influence of other boxes taking chunks out of corners. But it's the power of working within functions and working with the GH node. Not saying you couldn't do it in Grasshopper, but let's just keep things simple, and you can kind of visualize what's happening within that. So what's happened here is I'll take this geometry and I'll get rid of it, and we will put everything on. So what's being generated is initially this GH-Python node, and I've made a point and I put a circle on it. So you basically have one circle above, and we'll take this down and maybe do this in shaded. And so that's the attractor point that can be moved around, and I can play with that. And as I change that, it changes everything using the distance. But the script itself is quite simple. And although I get in here and I make some spheres, a list of spheres, a list of the distances, and a list of polylines, I'm not actually using the polyline. I don't actually have to print the distance, but I did here. It goes that out, and it's the distance from all the centers of these points to these points. And I'll use those later as a radius or something, or as a attractor point that will define the radius. I also produced a box down here, which I actually am going to find the center and do an orient to the center of all those points. So I'm going to use those boxes. But what I did with those boxes was just found a list item, threw them through a rotation, so I can actually play with those as they rotate from 0 to 2 pi, depending on the count. And what's happened over here is I've outputted these spheres over here. So as those rotate, I'm just doing a Boolean difference. And it does take a little while to run at 5.1 seconds, but that's what Booleans end up doing. The lines that I created in between them became the axis, and that was the axis lines were generated between the center of that point and the points here. So it's pretty straightforward to find out what's going on there. The node system is fairly simple as well. It is a triple nested loop IJK in XYZ, creating a point, appending that point, finding the distance of that point using the distance function. I did print those distances, which would then go into the output, and then I appended the sphere and made it there. What I ended up doing was I could have gone in and make boxes within here, and I was thinking of considering that, but it might make the GH-Python node a little too complicated to look at, so I decided to visualize that outside as a Grasshopper tool. And that's basically what you have. You've got this nice system that baked. As I go in, I can just simply grab that layer and bake it. It takes about a second. Leave the Grasshopper script. You've got everything you need right here. Throw it into your render. And whatever you want to do, you can take it into turntable just to appreciate it. And you could always throw it into an analysis tool to see what's going on. But it's not really that important. It's just rotated boxes disappearing within a generated nested loop of spheres. That's radius is dependent upon a attractor point. So that can be kind of fun to play with. Maybe I'll just show briefly what happens if I put it all on. And then you simply go in here and what happens to that geometry if I take that and move that sphere down here. I just have to grab that point and move it down. And it's just going to take a second because it's kind of upset with me doing that. I probably needed to deactivate. I should have locked the solver while I did that. There you go. See the explosion of that. Let me just lock the solver and just rotate that, pull that point down like this, and then I'll put the solver back on. Just by my middle scroll key, and on it goes. Unlock the solver and give it a second. It should take 5 seconds to run, and there you go. You've just blasted it into a whole other form. All the dots have become different. I can throw it into a bake. We'll do a little layer 5 just for a change of color, I think. in the renderer, and leave that. And there you go. You've got this totally other obliterated shape of spheres, which isn't so interesting. I actually don't find it that interesting. If I let me just go back in there and take that solver again. Take that solver off, find that point, and just lift that point up. And I think at this point we'll just pull it over to this side. And we'll take the solver back on and see what that did to the script. It's going to run it 5 seconds. And just because my count's low at 433 in the XYZ directions, I can go back in here and see what we have. There we go. It kind of blasted apart again, back to that first form that I kind of had. We'll just do a little bake over here. That should be fine. I think we're in rendered, so that's it. And there's a little purple showing up. So there you go. Not too hard to figure out some geometries. There's nothing too fancy about them, but you are able to use iterations which empower everything you probably traditionally were doing. And I am running it inside an interesting little function attractor, which I could start putting in parameters here and then inputting them down here when I run it, and that would make for a more different script as well. But we'll get into that at a later point. Anyhow, 6 minutes. Hope you enjoyed it. What I'm going to do is take this tool, that function. I'm going to add that back into this group. I am going to take that and put it to disable, and we keep that there. And we're going to go into this section now, which is dealing with curves. And we're going to start with some basic functions as I get these running, and get this set up for the next one. I think, except it seems to be wandering off right now, doing something weird. Enabling, and it's a pretty simple enable tool on curves. It's going to rotate these 3 curves, I think, that I had hard-coded in there. And this one's still deactivated because I missed it. Anyway, we'll get to it next turn. Enable, there we go. So you have this nice little script that came from what Niloofar was doing, and then also what we can end up Niloofar Zaker was up to and what she was doing in her initial ones, which were down here. As I pulled a lot of these, I started to play with them a little bit, but what I once again am trying to do is take these and jazz them up. So once I make something interesting out of this that's beyond the script she was introducing at an intermediate and somewhat grasshopper node, more advanced level, I'll show you what I'm doing. Thanks again for watching.